Before going to the actual hands-on workshop, the colleagues from the Technical University of Berlin, from the Natural Building Lab, are going to present to us the research that they're doing and how one can go forward into learning how to use recycled wood, waste wood. So, Sina and Julian, please introduce yourself.
Yeah, hi, thanks for the introduction. This is Sina, I'm Julian, we're both architects and research associates at the Natural Building Lab of the Technical University of Berlin. So we are working on the Natural Building Lab as one of the chairs of the Institute of Architecture. And yeah, we're both doing research on waste and also earth building materials. And what I'm showing you now is a short introduction for the workshop we are doing. So we show you a few of the research projects we are involved. Yeah, this is some basic information on the Natural Building Lab where we're working. Those are a few projects with our students. In our teaching, we are focusing on nature-based materials. And yeah, we call it resource-positive buildings, and yeah, we also focus on timber materials in construction and also on earth building materials. Yeah, and we are also focusing on alternative ways to produce architecture. So we are always interested in talking to the people where we are involved in our design projects. And Nina can add something.
This, for example, is a really small image of a building we built together with students, and the grid that you see is actually becoming a roof, and it's also made from reclaimed timber that we found on a demolition site in Berlin. So we always try to research and come up with ideas, but then also try to really do them, and while doing them continue learning, and then also maybe reconsider what our initial approaches are. So it's really nice that we get to do this hands-on format with you today, because we're going to prototype something from the previous research project, and we also have done it ourselves, so it's really about a mutual learning and experimenting with materials.
Yeah, so if you have any questions, you can just ask them in between the paper. This is our mission statement of the Natural Building Lab. So we see ourselves as part of the transdisciplinary network, which is collaborating. This is something I said before. We are always try to involve people who are also at the design building sites where we're working at. And we try to produce knowledge in our projects, which is then spread over the community. And always we test our design by producing prototypes in one-to-one scale to see if it's really working. And the main goal for this is to produce architecture for post-fossil society in the future. This is our team. This is from a team event we did. Now we are 20 people or something like this. So we grew over the last 3 years from a very small team to now nearly 20 people. This is because we managed to get involved in different research projects also. The question why we think about circular construction and earth building materials is those are numbers from Germany. It's always something we show in the beginning of lectures. The problem that we have that 55% of the generated waste are from the building from buildings, and 92% of the waste we generate or of the mineral resources we use are for buildings, and that's how we see that we need to think about other ways to produce architecture, and also to reduce the 40% of the CO2 emissions what the building sector is responsible for. This is the circular from the legislation in waste management, and this pyramid shows the main goal of rethinking how to design or produce the projects. From in the beginning, is always the first intent for us that we think about the reduction. So in the beginning of a project, when we want to build something, we always ask the question if it's necessary to build, and if there is some existing structure which we can use in order to prevent to build new stuff. And after that, we think about reusing building materials or components, also to reduce our impact in the design. And only after that, we think about recycled material. For example, the topic of waste wood is somewhere in between, because sometimes, so our main goal is to really reuse the material, and if that's not possible, we try to process the timber with as low as possible, that we don't lose quality of the material. And only in the end we think about the energetic utilization of the material. This flow chart shows a bit the situation that we have in Germany. So we have a lot of waste wood which is produced or coming up per year, and what you see in this whole process is all the wood which is going into the production of heating or something, and that's when the material is getting lost, and only a small part of the waste wood is going into new materials. And as you can see here, then it's always also needed that we put new material in the process. And this, for example, is when we have timber beams, for example, and produce something like oriented stranded boards, something like this. So chipboards, so timber material which has less value than the actual timber beam.
And this, of course, is representative for Germany, because we used to build a lot with wood, and like the historic buildings, like the roofs, for example, are done by wood. But of course, also other materials such as concrete or also bricks appear. And these numbers are, I'm sure, different, but to other material groups, we could also transfer this to a Greek context, for example. There's resources we use and we used for building, and then there's demolition happening, and then these resources go to waste. And the materials themselves, and also the resources that went into harvesting the materials at one point, also the planning that somebody did in order to design a house, for example, it's simply too valuable to just have these materials go to waste. I mean, on the CO2 level for sure, but then also on a cultural level, when we think of all the work and labor that went into these materials. So the diagram is representing waste in Germany, but it can be also, for example, brick or concrete and brick.
Yeah, now we want to show you two projects. The first one is presented by Sina. This is a project where we try to focus on the processes to reuse the timber, and the second one is a little building project in the middle of Germany, where we also had the design studio with students, and this is a timber frame construction where we see the potential of combining timber with earth building materials.
Yeah. And the title of the project is called Weber. It's a little hard to translate because we're really into word games. The German word game, so it's, I mean, if something has a good quality, it's often referred to as like A quality or something. And if it's a less good quality, then it's referred to as B quality or so on. And so what we're trying to do with the project is to come up with infrastructures, basically, with logistics that we need in order to turn waste from demolition sites in Berlin into building materials for new construction projects. So we want to turn the B into an A, and this is how the word game was supposed to be. Because what we realized is that if we want to propose something like this in a planning project, for example, or if we also want to research on this and we need access to material, we can't just simply go to a store, or we can't simply buy these materials somewhere, but we have to somehow get active ourselves and get really directly to the source and try to think of this entire value chain from having the material somewhere in a building used for the first time, becoming available because the building is being torn down, but then what happens next? How does the material from the first construction site comes to my storage space? What steps are necessary in order to transform this waste material into a new building material? How much work do we have to bring into the process? What are the advantages and what are the disadvantages? That's really all the questions that we had in our mind, that we have also in the previous project, and then we somehow have to come up with answers to. So what I'm trying to do is go through all these steps now really quickly with lots of images, because this is the part that we can't do today together, but we are then starting at the end of these steps, where we then build something with the material that we have been harvesting. So the first question is, where is the material? Where does it come from? And in what condition is it in? All the materials that we want to work with are materials that have been implemented into building without having the vision that someone at one point wants to reuse them again. So the way they are implemented in buildings, the way they are used, is not adjusted or planned according to reusing it. So it's not easy because no one thought of it. That's the first question. And then also, of course, there's all these safety concerns, because in the past we used different materials. So materials we, for example, thought they are safe, and then at one point we realized they're not safe and they're, for example, not healthy. So we really have to be safe and secure when going into these buildings and when researching or doing these initial testings and evaluations of the material. And then, of course, the material is, it's never just there. It's still within the building. We have these foils, we have different layers covering the material, for example. So we also always have to look at the time frame of the demolition site, and we have to wait for the right moment in which we can access the material and have a better understanding on how it's constructed and also what's going on. We have to understand how long are the pieces that we're working with, what are the diameters, and what are the measurements, and so on. So there's 3 images from 3 different buildings that all look quite nice. They been in use for a really long period of time if someone did not decide to rebuild or tear it down. So it's never, or it's in very few situations, it's really a question of quality, that the buildings stay stable and you could use them. It's really more a question of design and innovation, and then someone decides to tear down these materials. What we then always do, we also brought some data to look at. We take some samples and then we send them to a lab. We're coordinated to looking at like these samples we can't research on our own, but then the lab checks for pollutions, checks for sources that are substances that are not healthy, and if the material is safe to use, we get a green light. And in Germany, you somehow always expect pollutions within constructive wood, but at least in the few groups and materials that we tested, we very rarely found actual pollution. So the assumption of it being bad and of it having go to waste.
Sina, when you say pollution, what do you mean? Fungi or?
This would not be a safety issue, it would more be a stability issue. Then later on, no, I mean, for example,
They've treated sometimes constructions with wood preservatives
Okay.
to protect them against insect infestation or but it's
not wood generated pollution.
no. It's not the wood itself.
That's a really good question to make this clear. Once we then visited the sources and we found out that the material is safe to use and there's nothing we have to worry about, it's then all about getting this material in as large pieces as possible out of the roofs. And I don't know how it is here, but in Germany, the demolition practice, you're supposed to separate the different material sources when tearing down a building, but this does not mean that you have to take them out without destroying them. So the conventional practice is like this: you tear down the building and then you have people sorting the material, and this leads to demolition, and this leads to a point where the big wooden beams that we found in the construction site, they are small pieces and they are demolished while being taken out, and they would, if it would happen like this, they wouldn't work as a construction material, but it would only apply for recycling, so it was taken process. So what we've been doing is trying to convince the companies being in charge of the demolition and also the owners of the material in the buildings to somehow cut them out. It's hard to see here, but we tried to come up with a common strategy where to cut in order to get as much of the material as possible. And then the first is the theory, and then the other is then the practice. And here we were really lucky because they were really willing to do it the way we planned with them, and they were really taking out the entire beams out of the roof. But it's also always a question of time and of amount of work you have to put in, because it's just taking more time. So it's also a lot of convincing we should do. And the biggest issue for us was we found demolition sites, a lot of them, because that's just how the construction sector works at the moment. And until it changes, that's also something we have to deal with. And we found really cool partners who helped us take out the material and who helped us transport the material. But then we are lacking infrastructure. We're lacking storage spaces and places in the cities where we could, for example, bring the material and store it for a long period of time, because in comparison to a normal planning process where you make a nice design and then you come up with material that will fit, and then you have unlimited access to materials. When planning with reused materials, you have to think the other way around. You have the material first, and then you have to adapt the planning to it. So we need spaces and areas in the city to really hold on to the material for a really long time. That's another thing. But so we convinced the city of Berlin actually to let us use an abandoned site in the city, which is something that they don't use at the moment, and it has just a big parking spot, and it allowed us to really gather all the wood and store it on site. And the then following part is actually the most interesting one, because the material is different to fresh material. This means that we can't just use it as it is, but we have to prepare it accordingly. And what's a bit difficult about it is, as I said in the beginning, the construction was not meant to be dismantled, and the construction and the material was not meant to be reused. So we're looking at a lot of metal, screws, nails in the material that we have to take out before it can go into a machine, or before it can be processed in an industrialized way. So it's been a lot of planning work we've been doing together with students from us in Berlin. We did summer school, but also in other seminars we were experimenting on approaches and how to get it out fast, and realized that it's not so fast. But this we can't do today because we didn't get to bring beams in our luggage. And then, complicated and maybe not so interesting, but at the end the crucial part is, if you want to build with material, it has to be certified. And in order for it to be certified, it has to fulfill certain requirements that are defined based on fresh and new materials. So for old materials, it's really hard to meet these criteria, and it's really hard for us to prove that the material has a good quality and that it's safe to use. And that's something that we have to do now. And there's different regulations in Germany that explain how it should be done with fresh wood. They are not qualified for waste wood sorting, but we focus on these processes anyways and try to measure. And sometimes it changes in geometry, sometimes it's getting gaps, sometimes it's also old wood where you didn't have to cut off the part where the outer skin was. So it's all these things that you have to find out. And what we are now currently working on is the then processing afterwards. For example, if you want to produce how do we need these lamellas, these boards, this one, so that they can then go into the machine and be sorted and then glued to large amounts. But what we have been also doing with students was to really experiment a bit with the question of how can we construct a building when we don't know in the beginning how the material or what material we have available. So especially in terms of load-bearing structures, we are probably facing short pieces of wood or pieces of wood that have a really small cross-section, for example, and that is usually it's a challenge. But if we look, for example, at different construction principles, then you can have really wide-spanning structures with also really short and also really thin pieces of material, which is maybe something how the planning will have to adapt to then to the different material. That's it. Not entirely.
Not entirely. So what we want to do today in the workshop is to combine this timber with earth building materials, and I'd like to show you now a little project where we work with both materials. It's a little house in the middle of Germany where as a building type, it's called timber frame. So it's a combination of the load-bearing timber structure and the infills of the walls made from earth building materials. In this case, a combination of earth blocks and earth plaster. It's called wattle and daub. So it's in the infill, it's done with little branches, and then a straw earth mixture is applied from both sides, and this is then the infill of the wall. In historical buildings, you often see both those techniques. And from the building, we have a document where we exactly know from what time the timber elements of the building are. And here you can already see that the timber frame house can be very old. The conventional constructions, or for example concrete buildings, we don't know any building which is that old because we started just a few decades ago. But for timber frame structures, we know that they can reach really high duration. And here in this picture, you see that in the history of the building, some of the timber elements already were replaced by new ones. So, for example, those horizontal yellow lines here, they are made from the 20th or 21st century, and the vertical lines are from 1900, and there are still some timber elements in the building which are even older. And yeah, this shows that it's possible to repair constructions like this. Yeah, and the combination of the earth building materials and the timber is working quite well because both materials are in a way soft enough that they can both move. So when there's over the time when there's movement in the timber elements, the earth can also adjust to the movements. This is something which cement-based mineral material, for example, can't, and that's always when you see cracks in the substance when this is not possible. And that's why we still want to do research on the combination of the two materials. These are pictures from the workshop we did in the building, where we applied new plaster. And here's also a detail from the slab elements, and this is also something which we now are trying to research in the Venus project, where we again want to combine the earth screed with the timber slab. Yeah, in this project we could also in the workshop we could redo the historical techniques. And here you see also something which is very great about earth building materials. We have the possibility to remove them from the structure, and if they are not treated with any harmful substances, you can just put water again inside of them and then reuse them as they were before. So here you see the bricks we had to remove from the inputs because we had to exchange some of the timber elements, and then we could reapply them again after we changed the timber elements.
I think what we wanted to show also with the not every building in Germany looks the way that we just showed. It's a really traditional one, but especially when we look at nature-based materials and also the reuse of materials, a lot of the things we need is actually already there. We just have to look back to craftsmanship before industrialization, for example. Also the reuse of materials has been a common practice at some point in Europe, just because we would value the resources and the materials enough. And so it's now really, and that's also what's exciting about the Venus project, it's also about taking what's there and then reinterpreting it to today's needs and also the needs that the planning today poses. And so, we can learn a lot from old buildings, but we also can make new things out of it, and that's what we're going to do now.
With the